We are now ready to finally take a look at the sine function. So this is a momentous day for you. Now, don't imp out on me here. I want you to participate as we're going through. So on your paper, in your notebook, or on your marker boards, I need you to make a grid that looks a little bit like this. So I've set it up to go from negative 360 degrees up to 360 degrees. I also made one in radian. Now it's going to be the exact same graph, but just different units of measure. So negative 360 degrees, well, that's negative 2 pi in radian. Positive 360 degrees, that's positive 2 pi in radian. On the top, I'm counting by 90-degree increments. And on the bottom, counting by pi over 2 radian increments, because those are the same thing. Notice that the height, and in both cases, it goes down to -1 and up to +1. Turns out there's no need to go any further than that. So take a moment, get your grids made, and then when you're ready to go ahead, let's get back to it. Okay, tell you what, let's start with the one in degrees. I'm really going to make the same graph twice. The second time is just to get us more practice with radian. But let's start with the one in degrees. And let's do it by thinking about how we're now defining our sine function. It is when you have an angle, you go to the unit circle, you make that angle, and you look at the y coordinate where that angle intersects the unit circle. So start off right here in the middle at 0. For a 0-degree angle, that puts me right here at this ordered pair. So if I've just gone straight across, not up or down, then my x-coordinate's 1, the y-coordinate's 0. For the sine, all I care about, cosine is the x, sine is the y, all I care about is the y. So when my angle is 0, my sine is 0. Let's put a point right there. For the next angle that's easy to do, that's actually going to be 90 degrees. So a quarter rotation to right here. That puts me at this ordered pair. 0, 1. Again, the sine is the y coordinate. So the sine of 90 degrees ends up being the number 1. And I hope I can convince you, as you look at the unit circle, your sines aren't ever going to be higher than that, because this circle never goes higher than that. Sine is the y coordinate. The highest it goes is +1, and right there it is. So in between, the question is, well, how does it change? Does it do something like this? Does it do something like this? Does it do something like that? How do you know how you get from one point to the next? For that, I would like you to go back here now to our unit circle, and I want you to turn on this folder. So click in front of the one where it says the sine function, and that will turn some things on. Now take this angle, and I want you to rotate it from straight across to straight up. So in degrees, that's our 90-degree rotation. And I want to explain what's going on here. So this point here is moving along the x-axis so that the x-coordinate is the angle we're using. So because it's measuring in radian, it's pi over 2 right now, but that's equivalent to a 90-degree measure. The height, it's drawing in here this horizontal dashed red line. I hope you can see that the height is just the y-coordinate of this point, where you have the terminal side of the angle intersecting the unit circle. So it's the sine value. And then the solid red line is just tracing out the path that this takes. So something like this. So we go kind of straight up, and then we kind of flatten out. That's the growth pattern we take to get from this 0 up to this 90. So I'm going to do something like this. Goes up and then kind of goes flat. Okay, let's look at another 90 degrees. So as we now go from 90 to 180, that puts us down here again. coordinates now, -1, 0. The sine is the y coordinate, so we're back at 0. How does it come back down? Well, I hope I can convince you it's going to be doing a kind of a reverse image. So it'll come down a little slowly at first and then drop more quickly as you get closer to that 180 degrees. So something like that is what we're after. Now back to the Desmos sketch real quick. Extend your angle to go to a full half rotation. And yeah, we're going to see that particular pattern showing up. Right there it is. So this is what the first half of a sine cycle looks like. Let's keep going. This is fun. Let's go now to a 3/4 rotation, which in degrees would be to 270 degrees. That puts us down then at this point, which would give us what? 0, -1. The y, that's the sine. So down at -1 this time. And it's going to be kind of a mirror image. So come down quickly and then kind of flatten things out. And as we look at our Desmos, comes down kind of quickly. And then as we continue to rotate, keeps going down, but not very fast until eventually we get down to our bottom at a height of -1. Okay, let's then finish out a cycle. So if we go back now this way to a full rotation, we just end up back where we started. So at a height of 0, and it is going to follow that same kind of flat at first and then a little quicker as you go. So something like that. And let's just see that take place here. I've also set it up so you can move this one. Let's move that one there. And there you go. That, my friends, is what we call a cycle or a period of the sine function. But here's the thing. You don't have to stop there. Your angle, so if your angle now is bigger than 360 degrees, you just keep going around. So your graph would keep moving to the right, but it's just going to now repeat this same pattern again. The sine function is just going to continue doing this same thing on and on and on forever. But it gets even better because if you go backward, so imagine that instead of starting off going this way, what if I started off going down this way? Well, there's no reason you can't. And the sine is defined the same way. Nothing is going to be changing there. So this cycle repeats itself in reverse in the other direction. As I go down here, I'm going to have these negative signs that dip down to -1 and then come back up to 0. So something like this, come down quick, go flat in the middle, and then go up quick again. There you go. Continue to a half turn in the negative direction. That gets you back here. Then a 3/4 turn in the negative direction would get you at the top of the unit circle. Ooh, we're going to pretend that's a little better than it is. And what you'll see is this up and down pattern just continues indefinitely in both directions. So I've got a new Desmos here, just so we can type it in. If you type in y = sine x, that's exactly what you're going to see. It's this graph that goes up and down. Because we're measuring right now in radian, it repeats every 2 pi. Repeats every 2 pi as you go along. And I believe that's the moral of the story. This is what a sine graph looks like. Now, when you switch over to radian angle measure, nothing changes. But just for practice, I want us to become more familiar with how those radians work. So 0 degrees and 0 radian are the same. 90 degrees, that's pi over 2 radian. That's going to put us at the top. A half a turn, that's pi radian, gets us back down to a height of 0. 3/4 turn, that's 3 pi over 2 radian, gets us down to a height of -1. And then back to 0 at the 2 pi. And then the same pattern repeats in reverse. And then you get something a little bit like this. Notice the shape hasn't changed. It's the same graph. All that changed is that now, instead of repeating every 360, we're going to pretend it's got a little bump on it. We'll shave that off. Instead of repeating every 360 degrees, this graph repeats itself every 2 pi radian. One last definition that I want to give here in this particular part of the recording is to talk about angles that are coterminal. Coterminal angles end up in the same place in the unit circle and therefore have the same sine and cosine values. Here's what I mean by coterminal angles. To say that something is coterminal just means that even though the angles are not the same, they ended up in the same place. I'm going to give you a quick example. I'm going to copy my unit circle, give myself a little bit more room. I want you to imagine these two angles. Let's go in degrees just for practice. 330 degrees and negative 30 degrees. 330 degrees, that's not quite a full rotation. So it's going to be right about here. This is the terminal side of this 330 degree angle. So I went 330 degrees around, leaving 30 left over that I haven't covered yet. Now a negative 30 degree angle would look like this. You'd start in the same place, you'd go 30 degrees in the other direction, and lo and behold, you'd end up in the same spot. It is for that reason, because these angles are coterminal, because these angles end up in the exact same spot, that if you now check your sines and cosines, I'm going to switch my Desmos over to degrees. If you do the sine of 330 degrees, and if you do the sine of negative 30 degrees, you get the same number. If you do the cosine of 330, and if you do the cosine of negative 30, you're going to get the exact same number. So negative a half, 0.866, 0.866. It's for this reason, because those angles end up in the same spot. We see that showing up here in this graph. If we pick an angle between, say, 0 and 360 degrees, if you then just go back a cycle, like let's pick this angle right here. Hey, this angle right here. Hello. If we go back one cycle to the corresponding point over here, then this angle and this angle are in the same spot on the unit circle. They are coterminal. The same thing is true in radian, just means that if you would graph them the way we practiced in the previous lesson, they end up in the same spot.